If you've ever played an incremental game, you've probably noticed that some of those numbers can be incredibly huge. Some games limit themselves to the standard integer values, some of them limit themselves to the standard float values, and some of them limit themselves to the double values. But you might have run into a game that gets all the way up to the 1e 1000 or huge, ridiculous scientific numbers. And I'm going to show you how they do that. So I've got this game here. It's pretty simple, but I have a butterfly that has 1e 1000, or 1 times 10 to the 1000 health. So in other words, there's 1000 zeros. I think that's a Google. And I have a player who has a comparable attack. It's 2.5 e to 999, or in other words, about 1/4. Actually, it's exactly 1/4 of the mob's health. So if I actually play this game, it should take 4 attacks for that mob to die. So when the mob initializes, it's a butterfly, 1, 2, 3, 4, and the mob dies, and everything stops. There's no more attacks. So now we notice the mob's health is 0e999. That's great. That's exactly what we want, right? How do we handle that? Well, most integers in these programming languages that are typically used for programming or developing games, they can't handle numbers that large. So the way that we handle it is we have to create a custom structure in C#. You can do something similar, create custom classes in Java, or you can do the same thing in C++. But what we do here is we create a custom structure to break apart that number into a significant figures value, or the base value, and the E factor, or the power of 10 value. And so that's what I've done here. Rather than store my attack and my health using integers, I store it using this custom structure I've created called science number. So this would be the same way that you would represent these numbers down here. 3.4E38, that's a 3.4 is the base value, and 38 is the E factor. Now, of course, this comes with its own challenges. You can't add, subtract, multiply, or divide these numbers directly. These structures don't natively automatically add and subtract because they're custom, right? So we need to build our own custom subtraction structure. We need to build our own custom subtraction operator and our own custom division operator. Later on, we'll probably do a multiplication and a addition. But right now, we've just done these two because we only use it for these displays and health damage capabilities. But looking at this, what we're doing is we're actually just overriding, or we're creating our own subtraction capability in the rest of our programs, that we can take two science numbers and subtract them. Here, SN1 minus SN2, we go through all of this logic to calculate the output. So for this example, we're going to look at SN1 being 1e to the 10, or 1 times 10 to the 10th, or 1 with 10 zeros after it. And SN2 is 1 with 9 zeros after it. So for this example, both of them have a base value of 1, but SN1 has an E factor of 10, and SN2 has an E factor of 9. So the expected output would be when SN1 is subtracting, or when you subtract SN2 from SN1, you should end up with 9E9, or 0.9 e to the 10th. So let's go ahead and let's walk through some of this logic. So what we do first is we need to find the difference in factors. Right here, the difference in factors is 1. It's 10 minus 9. So we know that they are a difference of power of 10. Power of 10 to the 1, or just 1 power of 10. I'm struggling with language today. So what we do first, before we get too far into the nitty-gritty, is we say, hey, is the difference so increasingly huge that it's negligible? In other words, am I trying to subtract a number that's over 1/100 millionth the size of the one I'm currently working off of? If it's so small that that's the case, don't bother. If the health of my enemy is 1/8 bigger than the damage of my player, don't even calculate it, because by the time the players actually killed the enemy, the player themselves would probably be dead in real life. So there's no point in calculating that. It's a waste of processing power. But if it's not, and if it's within a reasonable difference in factor, what we do is we convert that SN2, that science number 2, into the same factor as our science number 1. So rather than being 1e to the 9th, we convert it to 0.1 e to the 10th. And now, because they're in the same factor, we can subtract the base values. So SN1 minus SN2, or 1 minus 0.1, and we end up with the correct output of 0.9 e to the 10th. However, this is a problem because our base value rules is it has to be between 1 and 9.99999. If we don't keep this rule, it's very hard for us to actually properly put out the scientific number. The scientific number should be that restriction. So in order for us to fix this, first we check to see, hey, did they zero out? Was it an exact subtraction? If we don't check this, some of this logic down below will end up being divisions by 0 or log base 10 of 0, and that ends up being not defined. So you either get NaN or you get negative infinity values everywhere, and that's no fun, and it doesn't work very well for games oftentimes when you have infinity values showing up. So we handle that right here and nip it in the bud, and we say, hey, if the base value is 0 now, just return the value now because we know it's 0. There's no point in calculating the actual exponent because it doesn't matter, or the power of 10. It's not an exponent. But if it's not 0, in other words, there is still something different. In this example, 0.9 e to the 10th, we need to convert it back to its correct science number notation. So now we find the difference in the e factor change that we need in order to get it back to its original proper notation. To do that, we take the absolute base value, so here 0.9, and we put it in math log 10 of 0.9. That ends up being, I think, negative 0.04. And we floor to int that, meaning we take it and we bring it down to the closest int, the closest integer. So negative 0.4 gets brought down to negative 1. So in other words, in order for us to convert 0.9 E10 into the proper notation, the change in E factor would be negative 1. So what we can do then is we can add that change in E factor to our E factor of that base number. And so that becomes 0.9 E10 minus an E factor, so it's 0.9 E9. And then we would multiply that base value times 10 to that E change, or 0.9 E9 times 10, or it'd be 9 E9. And that gives us a correct scientific number to spit out. And then that allows us to do that simple subtraction. It's not really that simple, but that's how you can do some operators with those custom values. Now, of course, if you were to make these modifications to a pre-existing game that uses integers and doubles, you'd probably be making changes to probably half of your scripts in the entire game. So I would advise doing this out of the gate and building your entire game around these values, because if you don't, it's going to become increasingly more difficult to implement these extremely large numbers. But for those of you who are interested in just starting to build a game and you want to build an incremental game with numbers that go beyond the standard limits of integers, doubles, or floats, consider building a custom structure just like this. Anyways, if you got any questions, feel free to shoot them down in the question box, the comments down below. Otherwise, thanks for watching. Have a good day.